Hi. Alright, Maths with Kumar again, back. As I said to you, the power of maths makes you an amazing person of substance because it gives you a sense of logical reasoning and an analytical mind. Now, anyone who's got a very strong maths, you realize they're able to go through decision making in a very sound way because maths is about precision, getting it right. It's not about being flowery and playing around with words. It's you got it, yes or no. As I said, maths is either, that sum is either right or wrong. So Maths with Kumar will be easy as I take you on this journey. Today, the focus is on inequalities. The very fact they call it inequalities, that means they're not equal. Equalities means equal. Inequalities means not equal. Either you're more or less. What is it? We want to find out. If it's more, under what condition? So for inequalities, you ask me for rules, alright? Now actually there's hardly any rule. If x is less than 2, yeah, x is less than 2. But if we have, like here, minus 2 is less than 5. You got it? Minus 2 is less than 5. If I multiply both sides with minus, alright? I multiply both sides with minus. Alright, this is a 5. Now, the sign of the 5 here is a plus. And if I multiply here with a minus, look at that sign. Minus and minus, what do we get? Plus 2. Excellent. And minus and plus, what do you get? Minus. So, this becomes bigger than that. Do you see that? 2 becomes bigger than minus 5. So, the change of sign, smaller to bigger. Now, how do you recognize inequalities? Now, we talk about linear inequalities means straight line. Not linear, it's a straight line. Quadratic and whatever inequalities, they're curves and bends. Now, when we look at this, alright, equal is like this. This is the small n, small. This is the bigger size. Small number here, bigger here. That means if I put x is less than 5, x can be any number less than 5. Remember the shape, small, big. If I put this way, big, small, like 5 is bigger than 2. Alright? So do you need memory to learn by heart? Learn. Bigger, smaller. No need. Alright? It's a simple logical reasoning of your shape. Listen, this is the big N. That's the small n. Minus 2 is smaller than 5. So if you multiply both sides, you can see that 2 is bigger than minus 5. So the first rule that becomes, if A is smaller than B, or if A, let me put as smaller, I taught you smaller, right? So right, say it this way. If A is smaller than B, if I multiply both with a minus, I get a minus A and a minus B. The smaller will become greater. So that's the first rule of inequality. When you multiply both sides by minus, smaller becomes greater. Now this is just the first rule. Take note of that. Ding ding. Let me put this sign, means important. Now the next thing is, if I have, alright, if I have like, let me say, if I have 3, alright, upon 5, okay, 3 upon 5 is bigger, it's bigger than shall I put it as minus 2, right? 3 upon 5 is bigger than minus 2. Of course, when I bring the 5 over, it's just a change, just move it, alright? Divide becomes a times. So I say 3 is bigger than minus 2 times 5. 2 times minus 5 is a minus 6. So you say that 3 is bigger than minus 6. Alright, fine. But what happens if I have something like this? Show you, if we have a number like, if I have minus 3/5, alright, is bigger than minus 2. Do you agree with me? If you draw a number line, if this is your 0 and if this is minus 3/5, minus 2 is further down. I multiply both sides with a minus. So this becomes a 3/5 and this becomes a 2. Minus times minus is a plus. A plus times minus again here times a minus becomes a plus. Now 3/5 is smaller than 2. Got it? Good. Now what happens if I have, so what I'm saying that the greater sign will change to a smaller sign when you multiply with a minus, alright? Or if you bring the divide of a minus number over, it becomes the change of sign. Alright, if I have A bigger than B, alright, and I multiply both sides with minus, okay, I have a minus A and I have a minus B. The sign from bigger will change to smaller. So this is what we are trying to advocate. Look at it logically, ask yourself some sensible questions, and it will become a lot more easier. So inequalities is about not being equal, bigger or smaller. But sometimes when they put a sign like that, it means it can be smaller or equal. If I put A is less than or equal to 2, so A is any value from 2 downwards. And they say it's an integer, so A will be, A can be a 2, A can be a 1, a 0, a minus 1, a minus 2, it can go on and on. It's just an integer, if they say. Alright, so take note of that reasoning. Now we need to do a little bit more, and then we'll be very familiar with the laws of inequality, and that makes us comfortable. Basically, inequality is about like equation. When a plus moves over, it becomes a minus. When a minus moves over, it becomes a plus. Times becomes divide. Divide becomes times. But the change of sign, that inequality sign will only change if you multiply both sides with minus or you divide both sides with a minus. Alright, let's have more examples of it and then you get familiar with it. Inequality. Right, great. Look at this. The first example that I'm going to go through with you. 2x minus 5, hey, is smaller than 2, bracket 1 minus x. A very simple linear equation. Just open up very comfortably and say, hey, 2x minus 5. You're bigger than 2 minus 2x. Just open this up. Minus 2x moves over. It's a minus. It becomes a plus 2x. And then your 2 is here. Minus 5 moves over. It becomes a plus 5. What we've got is a 4x, and a 4x is greater than 7. And you can see from here that your x is greater than 7 over 4. 7 over 4 is about 1 3/4, right? So if they tell you, hey, what is the smallest prime number here? You want a prime number? X will be 2. Of course, I can't tell you what's the largest prime number because it's never ending. 2, 3, 5, 7, 11, 13 goes on and on. The whole list as long as it's greater than that. If they ask you what is the largest integer, it's also going on. X integer is a whole number, remember? But the only difference between an integer and a whole number is actually 0, 1, 2, 3, 4, 5. Alright, they're whole numbers. Whereas integer can be positive, it can be negative, and it can be a 0. Okay? Alright, so look at this. This is what you do. And this is actually called a rational number. A rational number is a number that's expressed as A over B. That's it. Now let's test it. Alright, I know you're just as curious. Alright, you're a young little thing. Sorry if you're matured. You feel big. Great. Alright, I remember when I was your age. Alright, the first time my eyes caught on an attractive guy, and my heart gave way. My heart went ticking, and I said, what's happening to me? Oh my God, I didn't know my hormones within me were changing. It's only now as I grew older, and I said, oh my God, when you are at this age, you face raging hormones. Ooh la la. Alright, I'll tell you a little bit more as I go on during my commercial break for lessons. Learning maths all the time can be boring. But raging hormones means your hormones can be so erratic. Alright, it can create some problems. It takes off your mindset from learning, gets you distracted, and then you have to manage your RH. And that's how you get in control. In maths, you need to do a lot of that. Alright? And of course, you have a curious mind. You want to find out more. But let's not go into sexuality. Let's look at this curious mind. She says X must be more than 1 3/4. You say, I say. Fine, let's put an example. Test it. X is 3. Example. Take X as 3. Bigger than that, right? So you put 2 times 3, 6. 2 times 3 minus 5. What do I get? 6. Take away 5, I get a 1. This is my left-hand side. Let's look at the right-hand side. 2, 1 minus X, 1 minus 3. What I get here? Minus 2, right? 1 take away 3. Minus 2 times 2 is a minus 4. Isn't this bigger than that? Yeah, bigger. So it satisfies. Let's take another value. What number do you like? You want to take a minus 2, alright, because you said, okay, is it true? Let's take a number that's smaller than this number. Or take a 0. 2 times 0, 0. 0 minus 5, minus 5. Now you put 0. 1 minus 0, 1. Times 2, 2. Is minus 5 bigger than 2? Oops! No. So it satisfies, you see. It cannot happen. X must be bigger than 1 3/4. When we put X as 0, it does not work. Even if X is 1, 2 take away 5 is a minus 3. Yes, here, you take a 1. 1 minus 1 is 0. 2 times 0 is 0. Minus 3, not bigger than 0. Oh, no. But if you take as long as a number above this number, alright, it will definitely take place. As long as bigger than 1 3/4. One number big, even one number like this is 1.75. Alright, this 1.75. X is greater than 1.75. You take 1.76. Let's test it out. Alright, you're curious just like I know I need to satisfy the curiosity in you. We take X as 1.76. Let X equals to 1.76. Right, put down there 2 times 1.76 minus 5. Ding ding, you get minus 1.48. You get your this side to be minus 1.48. Let's put here again now. This side will be 2 bracket 1 minus 1.76 close bracket. You get 1.52. You get this side is 1.52. Isn't this bigger than this still? Isn't this, my dear, this is negative. Negative. It's nearer towards 0. This is a little bit away. Alright? As long as it meets that condition, you will find that any number that meets that condition, when you substitute in, it will be satisfied. Test me and you can see it. Just test yourself and say, is it true? Alright? Okay, my dear, let's look at this sum. What is it all about? Alright? I know your curious mind will want to work on it and look at it. If it's wrong, come to me. I want to know who you are and what happened. If it's wrong, it cannot be. But if you are proving it right, if it's really true, oh God, I don't know what is happening to the world of maths. Okay, let's look at this. They said greater or equal. The bigger number is here. The smaller number, because you look at that and big, small, or equal, they balance. Okay, so let's look at this. What does this mean? 1/4 times 2x minus 1. Alright, 2x, multiply this by a quarter, dung dung, you get a half x, multiply by here, you get a minus a quarter. This is 2/3 x. Bring all the x together. Alright, half x. Alright, this is a plus. If you bring it over, you get a minus. Bring the quarter over. You don't change signs like that. The inequality sign still holds. You only change sign when you're multiplying with a minus on both sides, or you divide by minus on both sides. Alright? So now this is 3/6 minus 4/6. Right? You change it to sixes. 3/6x minus 4/6x. You get a minus 1/6x. Is greater or equals to 1/4. Now, I could write it this way. Am I not wrong? I could write it that way. I just bring the 6 over, divide, come here. It becomes a times. So I get 1/4 times 6, cancel it, 3/2. In other words, minus x is greater or equals to 3/2. Multiply both sides by minus. When you multiply both sides by minus, the x will change. The sign will change. Oh, bigger becomes smaller. And you get a minus 3/2. Both sides are multiplied with minus. In other words, for this answer to exist, your x must be smaller or equal to minus 1.5. Alright, have you got it so far? Alright, so we just did like a linear equation. We moved things over, just like how you solve an equation. We only change. The rule in inequality is when you multiply both sides with a minus, then you change the sign. Now what happens after that? I take a sign. I take, like, for example, x is 2. Does it satisfy this? X must be smaller than minus 1.5. Alright? X must be smaller for this to be true. Otherwise, no way. And I want to defy it. I take x as 2. Let x be 2. Let's see if this condition is satisfied. X, you are 2. So this is 4. Alright? 4 minus 1, 3. 3 times 1/4, you get 3/4 here. X is 2. 2/3 times 2. What I get? I get 4/3. 4/3. Is this satisfied? No way. It's not. This is smaller than this because it did not satisfy this condition. Alright? Let's take if it satisfies. X is smaller than minus 3/2. If we draw a number line, this is 0, this is a minus 1, this is a minus 2, minus 1.5 is here. That point there is a minus 3/2. From this point onwards, any number that you fit into the equation will satisfy this equation. Let's take x as a minus 2. What do you get here? 2 times minus 2, what do you get? Minus 4. Minus 4, alright? I'm taking the x to be minus 2. This will be a minus 4 times 1 minus 5 times 1 quarter. I get minus 5 quarter. When I put here minus 2, I get, what do I get? 2 times minus 2, I get a minus 4 over 3. Isn't this bigger than this? Look at that. You get minus here, minus 1 and 1 quarter. It's certainly bigger, alright? Not even equal, it's bigger than minus 1 whole and 1/3. 1 quarter, alright? Minus 1 quarter is definitely bigger than minus 1/3. So this condition is satisfied. Try with more. Maybe you want to put 8. Maybe you want to put 9. Take anything. Alright, you'll see that it will not. It must meet this condition of x being smaller than minus 3 over 2. And the largest integer will be, what is bigger than minus 3 over 2? The largest integer will be minus 2. Alright? Largest integer. I say integer means I want a whole number, whether it's positive, negative, that satisfies this, it's a minus 2. Okay, take note of that. That's an integer. Alright, now how is that? Are you alright? Great. Now focus in maths. Focus, focus, focus. Let's look at the next sum. They said, hey, x is between these given values. What is it? X is minus 7, 3x is between minus 7 and 20. And what's the meaning? What does it mean? It means that minus 7 is less than 3x. That means if I divide it by 3, I get minus 7 over 3. Alright? This is smaller than x. What does that mean? It means that x is greater than minus 7/3. And minus 7/3, if you put it into a proper fraction, a proper mixed number, it will be a minus 2 wholes and a 1/3. It's bigger than that. And then the next condition tells me, let me look for red chalk. Okay, so we've got here, again, minus 7 is smaller than 3x, so we divided it by 3, so we get minus 7/3 is smaller than x. What does this smaller? This is smaller than that. That means that is bigger than this. So x is bigger than that. That means if we draw a number line, and if I have minus 2 and 1/3 here, and this is minus 2, minus 1, and if I have a 0 here, and I go on 1, from this point onwards, x is bigger. Alright? It's bigger than that's what it says this part. But there is again a limit. And what's the other limit? They said, oi, look at this part. 3x is smaller than 20. Oh, so what does this part mean? If 3x is smaller or equals to 20, x is smaller or equals to 20 over 3. So what is 20 over 3? 20 over 3 is, look at that carefully, 20 over 3 is 6 wholes and 2/3. So x must be smaller than 6 and 2/3. That's the other part, the condition. So if I draw a line, because I don't have 6 and 2/3 here, if I have here this point, x is minus 2 and 1/3, and here let me put as a 0, and here I have a 6 and 2/3. X is smaller, and that's an equal point. Sorry, here doesn't have an equal, so we just put not included, that point. It's just not included from this point onwards. But this is smaller or equal, so we shade it from this point onwards. This goes on, and this goes right on. But they must satisfy within that range. So what does it happen? Hey, you are going on and on and on. You're going on and on this way. But we must satisfy because we're given within that range. The limits are there. So x is from here to here. So what is the condition then? X satisfies between x is bigger than minus 2 and 1/3 and smaller than 6 and 2/3, or equal, because there's an equal. And the largest integer value here will be a 6, because you have 6 and 2/3 stepping out of 6, 6 and 2/3, so that's your largest integer value. The smallest integer value of this, as it goes on, 6, 5, 4, 3, 2, 1, 0, minus 1, minus 2. Alright, which is within the range. So the smallest will be a minus 2. And the largest rational value of x. Rational means a number that can be expressed as A over B. So you look, this is included. So this is the largest. And the largest will be, change it to an improper fraction, A over B. 6 times 3, 18. 18 plus 2, it will be 20 over 3. That's the answer for this. Alright, we've got these answers for these sums. Now I hope you've got it, alright, about inequality. And I'd like you to take a little break, alright, for a short while before we come to the next word examples. Listen to this song called Puppy Love. It's by Donny Osmond. I would like you to get the original song. It's not your days, but it's my days. And it helped me manage a lot on my raging hormones. It helped me understand what it's like to focus and to stay away and manage your sexuality. Right? Along with maths, we learn many things together.